And welcome to part 18 following the restoration of our 2-foot gauge Fowler, Tully Sugar Mills number 5, works number 16341. This episode we'll be doing the boiler, but first finishing off from where we left off in the previous video on the valve gear. This is boring out the end of the combination levers, and then we're going to ream it with the reamer that's sitting there. We've bored them out to the centres on the milling machine, reamed them out here to take a bush. We bushed the end of most rods, and we bushed the ones that had to have the pin moving inside them in cast iron, and we bushed the ones where the pin would be static in steel. This is the same process going on with the valve rod. The reason that we did that is because sometimes the holes weren't necessarily perfectly central because of wear. So in order for us to open them up larger to make them central in the correct position, we then had to bush them down to the correct diameter again, having moved the centre of the hole into the right location. So that's what's going on there. This is one of the bushes to show you the process of pushing it in. It's been chilled down, you've seen us do this before, in the fridge, so that it shrinks that tiny little bit, just a thou or two, which allows Neil here to get it onto this rod, which is the lifting link. And you just push it in there. So this is a dynamic bush, so this is a cast iron bush, because it has to swing, even though only through a tiny little area, as it's just lifting the engine from forward to reverse. There is a degree of rotation in the pin that will go through there, and therefore it's a cast iron bush. You can see it squashing in as it heats up until it heats up and expands, and therefore grips into that rod perfectly.
So that's pressed in nicely.
Nice. Cool.
Okay.
And the same process now on the radius rod, boring out the end that goes against the valve rod in the combination levers, and the other end prescribes the radius within the expansion link operating on the die block, sliding up and down. Neil here showing the flat surfaces have already been machined on the end of it so that it lies flat on the milling machine, and you can see one of the bushes that's already been pressed into there earlier to go on the lifting link, actually that you saw us pushing the bush into as well. The pins, brand new pins for all of these, because the pins that were in it were just worn. You can see there's a hole that we've machined in the end of these pins, and the hole goes all the way down the centre to this recess that you can see with the hole in it in the middle, and that's for us to be able to put oil into. Now what we're going to do is press one of these little pre-made oil caps into the end of each one. They have a little ball bearing in the end that's sprung loaded, so Neil here is putting Loctite on them. He's going to put it on the end there, and then Neil will just tap it. It's a couple of thou larger than the hole, so it'll take a bit of a tap with a hammer to get it in there. Essentially, that'll allow us to squirt oil into the centre, past that ball bearing. The ball bearing will then close behind our oil can, stopping any dirt ingress, and it will fill that tube inside there up with oil and squirt it through the hole directly into the centre of any bearings that are moving in there. The original as-built design was just a hole in the top of each rod to put a bit of oil in, and we thought we've got the holes as well, but we thought these down the centre of the pins would allow us to make sure the whole thing was well oiled all the time. This next shot is just milling a little keyway into the end of a lot of the rods where the pin has to be static. In this case, again, the end of the combination levers. The pin that goes through here doesn't move. It moves on the end of the valve rod. So when you look at the end of the pin, we've got a little hole machined into that to take a key. You can see it there just behind the head, and there'll be a little pin goes in there which will locate in that slot that you've just seen as mill, and that will stop that pin rotating on that point. So essentially valve gear finished. Back onto the main subject of this video, the continuation of the restoration of our boiler. So a little bit of a recap to start. This is the boiler returning from the shot blasters. We had the whole thing shot blasted so we could see the wood for the trees and really do a thorough inspection on it and see what the plate work was actually like. We tidied up various areas, removing this extra strip that was welded in here, and you'll see that generally the boiler was good, but if you look on here you can see there's a chalk line. You'll remember again from earlier videos that after the inspection we found that the rust had got into the bottom of the back head and the bottom of the side that you can see here, and the boiler inspector felt we should chop those plates out and replace them with new, which is what went on here. Ian was grinding off the stay heads in a couple of seconds ago, here smiling at the fact we finally got that plate off, and you can see that the inner firebox surface was very good. The stays are all ground off and drilled off here, and they needed replacing. So the first stage of the process is to flame cut off the remnants of the stays, so that we can start taking them back to the plate and ultimately get rid of them completely, as you'll see in a second. Really, putting in new plate work in there was the first stage to make the plate work and put it in. The rest of the boiler was in very good condition. There's very little to do. There's occasionally some pitting that was localised, where the decision was made that we could fill that up with weld on the surface, which you'll see us do in a moment. This is Ian grinding those stays flush so that they were a flat surface. Same on the inside of the firebox here. Just, you can see they're still in above the area that we've chopped. And then once we've got a flat surface, Ian can dot punch the centres so that we can then get a drill on there to drill them out. At all times we're trying to preserve as much of the actual plate work as we can, so we drilled out smaller holes than the actual size of the thread, so we could then peel out the thread and leave as close to the original size hole as possible. Again, there goes the backhead plate to give us full access into the back there. The same process on those stays would have been done afterwards that you just saw with the flame cut, the grinding, the centre punching, and now the drilling. This is drilling out from the inside out from the inner firebox. You can see the angle grinder going on the outside there from my view on the inside as I was drilling out. So now we caught up. This is the new plate. This is the backhead plate being formed. So here on the 50-ton press, John Varley, our welder, and boilersmith, is in giving us a hand. He's heating up, and unfortunately I missed the actual press part. But you can see here it's been pressed with the two rams and a round bar to prescribe the correct radius in the corner there. It's been pressed to 90 degrees. Difficult thing to get accurate, so there's a little bit of fiddling that you'll see here, just going backwards and forwards to heat it, to put the bar in, to press it, to tweak it, just to make sure we'd got that accurate to the 90 degrees and to the curve that we wanted. And then, as you can see, John checking it with the angle there, make sure it's okay, and then that'll come off and be shaped to fit the side of the hole that we chopped in the boiler. So this is the same plate now being trial fitted by John. It curbs round the backside that you can't see there. He's chopped it with the radius to fit the original cut out backhead section. The hole in the back of the boiler itself has been prepped for the weld, so you can see that the cut out edge is now ground at 45 degrees to allow, and the new plate will be cut to 45 degrees as well. This is the bend to allow the new plate to be welded in properly, which will also be cut to 45 degrees. This is John having marked the area of the plate that's excessive, that needs to be chopped off, and then flame cutting here in a nice straight line by hand, trimming off the bottom, the excess, to make it fit. That edge that's being cut at the moment is the edge that will lie next to the foundation ring, so it's the bottom edge that you saw John marking to trim. Always fun watching metal melt. If you look here at the edge of the plate, right where it's being chopped through, you can see that the thickness of the plate's thinner. The plate, as you can see along the top, is 1/2 inch thick, and the thinness is because that section going round the corner of the backhead sits underneath the plate from the side of the backhead, and you can see here where John on the left is grinding it, you can see where the backhead plate will go round the corner, and if you look above where he's grinding the 45 degree angle in the plate, you can see the outer wrapper of the firebox sits on top of that backhead plate, and that's why both of those are thinned locally, so that the net resultant thickness is about the same as the normal plate. So to help hang the plate on the backhead, there's a hole being drilled here so that we can put a bolt through the plate into the foundation ring at the bottom, just to clamp it on. You can see there's been various pieces of metal tack welded onto the backhead here, just to hold everything in place, because even though it's a relatively little plate, it's still too heavy to hold up there. There's a plate on the bottom under the foundation ring to hold it. Here, both plates are now on, overlapping as we described earlier. John is just tack welding them on. So this isn't a firm finished weld, but they're tack welded. You can see the points here, so that they're in the right place. And then now that we've got them positioned correctly and set roughly how they're going to be, we can start lining up and drilling through the holes in the internal firebox to mark and then drill through the outer firebox plates that we've just made in readiness for the stay holes, so that they line up. We've made a little guide bush that fits the holes that are already in the firebox, and then Dave can drill through the hole down the centre of it to make sure that the hole that we're drilling, the mark that we're placing on the inside face of the outer plate that we've just replaced, is in the centre of the original stay hole. Then moving the plate onto the radial arm drill, which is what you see here, Ian's drilling down those marks that Dave's made, in this case in the foundation ring, so that the new plate has the holes in. You can see there's other holes in the plate as well for the stays. We've already done that in exactly the same process. All the holes were then drilled out, stepped up in size until they were the right size in readiness for tapping, which will be one of the next operations to do on those boiler plates. We took the opportunity whilst the plates were off to do non-destructive testing. So this white paint is sprayed on all of the areas where you think there could potentially be a crack. And then there's a blue dye put in there, and the blue dye gets stuck in the cracks and shows through the white paint. It's a good idea to do it while the inner firebox here is exposed, because once the plates are on the outside, like this, you're never going to see those bits again. So we took the opportunity to do that while we could. This is the plates in their final resting place, ready for welding into place now with all the holes in. So this is John Varley again, welding in finally the backhead plate. After that we flip the boiler over on its side, and this is John just sealing the joint between the end of the side plate where we've chopped it off and the throat plate, just sealing it up with weld before we put the side plate in the way. Looking at the end, you can see again the backhead around the side, that thinned plate that you saw us me talking about earlier. We've bolted through the foundation ring all the way down to make sure that the plate is sitting flat, and then John here is grinding back that end to thin it even further to try and get the side plate to lay as flat and in the correct position as you can. Same job here on the throat plate as it comes around the corner. Very difficult to get this new fresh clean half-inch plate to sit flat against the foundation ring unless you get those side plates where the throat plate and the backhead comes in thin enough to be able to take it. This is John checking with a straight edge, a piece of tube, that the foundation ring itself doesn't bow away from where we were trying to get the plate to lay flat, because it was really difficult to get that plate clamped down really hard so that we didn't have a massive gap along the foundation ring between the new side plate. In the end, we had to weld on this huge square chunk of steel that you can see there, and clamp that down as well to try and pull the new side plate in against the foundation ring so that it would be in the right place for us to weld it, which is what we managed to do here, and what you can see John in the first instance tack welding that plate in, as you can see here with the tack weld, so across where you just saw John welding, and then ultimately putting a proper seam weld down there and several times backwards and forwards in the trough to seal it properly. There's no reason for this shot other than it just looks really cool. This is the last bit. The final welds going in to fill the trough between the two 45 degrees that we'd cut there from the original outer wrapper and the new plate on the side, and as you can see John's filling that gap very nicely. Nearly at the end of this particular video now. The next stage was tapping those stay holes. We had a stay tap, which is an unusually long tap for getting through both the outer wrapper and the inner wrapper, but it was slightly blunt, so we redressed and tidied up and sharpened up the tap, which you can see here on our grinder. Just essentially going backwards and forwards along the old cutting edge of the tap just to sharpen it and make sure that all those individual teeth along there were sharp and good for cutting again. This is Neil sending it backwards and forwards through the grinder to tidy that up and to make it fresh and ready to cut. The tap was now ready, but tapping the stay holes was going to be a bit of a learning curve for us because it's thick plate, so we welded a couple of angle iron parts together to sort of simulate the boiler inner and outer firebox to have a go in the workshop, and it proved really difficult driving the tap through by hand. We tried it on the boiler and it was no easier. It was really difficult trying to drive it through by hand. And this is Ian stepping up to have a go, and you can see how stiff it is. So ultimately we've got a friend who has a boiler shop and some better kit, and we're going to decamp there for the next video to drive them through properly and get the whole lot done. A knackered old man. We're going to make our own stays though, and this is the fresh bar material coming to go in our CNC lathe for making those stays. But that's everything for this video. Thanks ever so much for watching. There'll be another one along, hopefully much quicker than the usual wait. Thanks again for your patience, and we'll be back soon.